Okay, so we're trying something new. I'm hoping I like this a lot better because it's a bit more convenient for me, and I think you'll think that it's easier. I hope that that's the case. I have to remember not to talk so loud because the camera's really close to me. So we're going back to doing the highlighting videos for a while. The reason being that there's a lot of stuff that you had to learn that it was really important that you learn. That's what makes these videos easier for us now. So now we're getting to stuff that you kind of need to know, but they don't go much further than you kind of needing to know them, I guess is the best way to put it. It's not like we're going to build on to this very much, whereas all the other stuff you've learned up till now, we build on a lot. So, and this is an example of us building on that stuff a lot. So there are some definitions. Remember, yellow is your definitions. This might look pink, but it's really purple. This is for postulates and theorems. We won't be using that much. It's getting less and less important that you write these theorems down, believe it or not. So if I highlight them, I might do in this section a very small bit, but a lot of times from now on, especially in the next two chapters that we cover, I'll be doing them in yellow if it's a formula you need to learn. If it's a formula that you're just going to be getting or information you're just going to be getting that is good information for you to know, but not necessarily something you're going to have to use in the future, it'll kind of be in blue then, because it's good information for you to know. And that's going to happen a little bit. We're still dealing with constructions, which you already started. You did constructions with my mom, hopefully over Christmas, if not before. And those constructions will be very beneficial to you. In fact, all the constructions that you have worked on for all those videos that you watched from my mom can all fit into sections 1 and 2 of chapter 10. That's why we did it over a spread out amount of time, so you'd have some time to practice them. If you have not practiced them, you're going to need to go back and start practicing them, because now is when you have to know how to do them. That is non-negotiable. So, because it's going to factor into your test that you're getting ready to take for this, there are exactly 3 videos until your next test, and this is one of those 3. So it's not something you get to play around with. You watched a ton of videos on how to do constructions. I hope you remember them, because you're going to need to know how to do them. Okay, let's go ahead and get started with section 10.3 and 10.4. So you have your book that you get to highlight in, which makes things faster for you. I have these papers that I get to highlight on, which makes things faster for me. And hopefully by the end of all this, you'll understand exactly what you need to know. Section 10.3 is all about words you need to learn definitions for. So it says the bisectors of an angle of a triangle intersect at a point that is equidistant from the 3 sides of the triangle. But the important part for you is to know that that point is called the incenter. So I'm going to highlight this in yellow. The bisectors are equidistant from the side of the triangle, and the point that they all go to is the incenter. They call them bisectors of the angles, which is what it did. It changed this angle up here, and it cut it directly in half. It cut this angle directly in half. It cut this angle directly in half. And where they all cross happens to be called the incenter. So you have to keep in mind that bisectors of angles form the incenter. Turn page. Go through. Oh, we're upside down. Oh no, hold that thought. Wrong page. And we're here. Sort of. I can work this out. Okay. Theorem 2. Perpendicular bisectors are the sides of a right triangle, or not of a right triangle, just of a triangle, intersect at the point that is equidistant from all the vertices of the triangle. And that point is called the circumcenter. They said that they were perpendicular bisectors, which means they have to form perpendicular lines. That's what all those right angles are for. And it said that this is a bisector, so it cuts each of these in half. So this line and that line and that line all intersect at that point, which is called the circumcenter. Now, it said that it was equidistant from the vertices of the triangle, which also means, interestingly enough, that this length right here is the same as this length right here, is the same as that length right there. So if you wanted to make this the center of your circle, all of these sides would touch it. All of those angles have to be a part of it, because that would be the center of your circle. That's why they call it a circumcenter, because it informs the center of your circle. Moving on, once again, notice I'm not doing these theorems in purple. You don't need to memorize the theorems, you need to memorize the definitions. The lines that contain the altitudes of a triangle intersect at one point, called the orthocenter. Down here, they were trying to get you to construct an orthocenter, and it's the way they give their instructions on constructions that I don't really like, and that's why I had my mom do all the constructions with you so you could kind of get a grasp on constructions. But they gave you a picture of what one of those triangles would look like. So they drew this triangle, which happens to look just like that triangle up there. I'm going to let it go. And then they wanted you to find the orthocenter. So you do that by finding all the altitudes. And you have to remember that an altitude is when you take a line and you drop it down from the vertex to the perpendicular. So I want this to form a right angle with the opposite side coming from that vertex. This to form a right angle with the opposite side coming from that vertex. So that's kind of what they look like. But when you are, and you can see it's definitely not the same spot. When you are constructing this, then you have to find the perpendicular to this line from that point. So it's almost like you're finding the perpendicular bisector, but we don't care if it's a bisector or not. We're just drawing a perpendicular line through that point to this line. So if you'll remember correctly, you put your compass on that end and you draw out some lines. And then you put your compass on this end somewhere. You draw out some lines and find out where it's perpendicular at. So that perpendicular line will give you this particular line that's perpendicular. Then you have to find another one. And they went ahead and found this perpendicular to that line. And they didn't bother finding the other perpendicular, because once you found two, you notice that I didn't have a problem finding this one because it has to go through there. That's the whole mathematical magic of it all. When two happen, the third one has to happen. That's why it's called an orthocenter. Okay, one more page, still upside down. It's going to happen all day, I promise. All right, one last theorem. The medians of a triangle are concurrent. The length of the segment of a median from the vertex of a point of concurrency is 2/3 the length of the entire median. The point of concurrency of the medians of the triangle is called a centroid. I don't really care so much about the theorem. It's this part, knowing that it's a centroid, that I care about. You've got to know those 4 words, basically. The incenter, the orthocenter, the circumcenter, and the centroid. You have to know what they all are. You have to be able to find them all. So then they want you to construct a centroid, but in order to do that, you're going to have to remember what a median is. So a median goes from a vertex to the midpoint of the opposite side. So they went ahead and they found the midpoint of this side by doing the whole perpendicular bisector, because that's how you find the midpoint. So they did the perpendicular bisector using both A and B to find the midpoint there. Now we don't care about the perpendicular part, we just wanted the midpoint. And then you draw a line connecting C to that midpoint, which they said was N. Then they went and they found the midpoint over here, which was N. And where they crossed, they made X. When you find the midpoint here, it's going to have to go through. They're always going to have, if you find 2, that means you've got 3. Now, just because it works out for us doesn't mean that it works out all the time. So you have a perpendicular here, but there's nothing that says that this is perpendicular. That is a perpendicular bisector because this is the same thing as that. But that doesn't mean that this is perpendicular or that this is the it might be the bisector, but because it separates the 2 of them, but it is not perpendicular because it didn't draw a little line. So just because you have a perpendicular bisector on one side doesn't mean you'll have it on all the sides. So you have to keep all those definitions kind of balanced in your head. Okay. Hold that thought just 1 second. All right. Don't hold that thought for just 1 second. What do I know? So that ends section 10.3. And we're going to go ahead and move on to section 10.4, which is circles. Using the same stuff, we're supposed to talk about to construct a tangent to a circle at the point on the circle. So this is our circle P. We want a tangent, our circle O, we want a tangent at P. So in order for it to be tangent, we learned that all tangents to circles happen to happen at a perpendicular angle to the radius at that point. So we need to make a perpendicular line here. So we're going to start by drawing our diameter between O and P. Nothing measured, just draw the line that connects O to P. Once you do that, all you need to do is form the perpendicular bisector here. So on this line, find your perpendicular bisector, which happens to be this line P right here. So that's how you form a tangent using the whole perpendicular thing. And then look upside down again. I'll straighten this out for the next video, I hope, if I remember. So here they want you to construct a tangent to a circle through a point on the exterior of the circle. So instead of it being on the circle now it's outside of the circle. construct tangent PT, construct a line PT, sorry, that's tangent to O. So first, they give you circle O and P out here. They want the tangent that's going to go through P and touch T, or touch your circle. So the first thing you do is you draw your line, connecting your radius to your P. Then you find that perpendicular bisector, which happens to be M in this case. So they found the perpendicular bisector, labeled it M. Then they created a circle around M that goes through P and O. So they made this the new radius. Instead of that being the radius, they made the whole thing the new radius. And they drew that circle. And by drawing that circle, you get the point T on the outside of the circle that it has to cross. To locate the center of a given circle. So when they give you a plane circle, they want you to call it circle O. All you have to do is draw any two non-parallel chords. That's kind of important. I did it in yellow, I should have done it in blue, but any two non-parallel chords, which is what they did, doesn't matter where they're at, make sure they are chords, preferable that they do not go through the center, just because that makes your life simpler. Then construct K and L, the perpendicular bisectors of those two chords. And wherever those perpendicular bisectors cross, that's going to be your center. So they found the perpendicular bisector here and the perpendicular bisector there. And that is how you get your center. Now, my mom would have shown you all this and taken a lot more videos to show you all this. But, you know, time is of the essence, and I need you to get the basics down so I could go through these kind of quickly. To circumscribe a circle about a given triangle, remember we had just talked about how to find that particular thing? They said that you draw the bisectors. So we construct perpendicular bisectors of any two sides. And I told you before, it didn't matter how many sides you did. It's if you did two or if you did three, it's going to be the same point regardless. So they did the perpendicular bisector of this side, and then they went and did the perpendicular bisector of that side. And the point where they cross has to be equal distance from all of your vertexes or vertices. So using that, you can find out what your radius is and draw your circle. You can also go inside, drawing the circle inside. So to do that, you start with the triangle. Then you construct the angle bisector of any two of the angles. So they went through and they did angle bisectors. That gives you your in-center. This one was your circumcenter. I think this one's your in-center. And that will allow you to inscribe it instead of circumscribe it. See how that works? That gives you your radius. Okay, so that takes care of it for section 10.3 and for section 10.4. Now, no need to look at this because this is not how we're doing classwork and homework. Instead, what I've done is I've drawn for you 4 different triangles. And you're going to have to listen to this carefully, and you might have to rewind it. But this is the way it goes. There are 4 different triangles that are on the printout that I sent your mom, the email that I sent your mom. And all 4 of these triangles are part of your homework. So you have to Take each of those 4 triangles, and I do one task at a time on all 4, and then go back and do the next task on all 4. And I used the protractor. You have to construct something. I need for you to construct an end center for each using a pen. Go over the end center in pink. So construct the end center. I don't care what color you use in order to do your construction, but I want your final end center to be in pink. Then I want you to go back through all 4 triangles and construct a circumcenter for each of those. Again, same triangles. Don't use a different piece of paper. Use it on the same piece of paper. Construct a circumcenter for each, and then put your circumcenter in blue. Then construct an orthocenter for each, and make your orthocenter green. Then construct a centroid for each, and make your centroid orange. Draw a purple circle inscribed inside of each, and draw a yellow circle outside, circumscribed around each. Once you've done all 6 of those things, take a picture of it with your phone or with your mom's phone, I don't care which, and send it to me. And that is your homework. I do not expect you to have your homework finished tonight. It'd be great if you could, but I don't expect you to. I know you have a lot of stuff going on, but I really need for you to get this stuff down, what each of those words means, and for you to practice your constructions a little bit. Otherwise, you won't be ready for your test, which will be kind of similar to this. So, there you go. Have fun. I will talk to you next time. Bye.